Hi, in this video, we'll be going over how to create a frequency table using quantitative data. You may remember from before that a frequency table with qualitative data is relatively simple. For example, if you have a bag of M&Ms and maybe there's different colors on the M&Ms, so red, blue, green, let's say brown, and these are the different colors. We might look at the frequency or count of each of those groups, and maybe there are 6 red, 7 blue, 2 green, and 5 brown for a total of 20. So all of this here, that is called a frequency table. This number down here, that is your sample size, which we usually denote with a lowercase n, and lowercase f is the frequency. We can also talk about something called relative frequency, which is just the frequency divided by the sample size. So if we did 6 divided by 20, that would be the relative frequency of the red. 7 over 20 would be blue. 2 over 20 would be green. And 5 over 20 would be brown, etc. And of course, then you can do the calculations like convert these to decimals, etc. So this is relatively easy when your groups are just different colors, different categories. But what if you have a data set that is quantitative, that looks more like this? Well, if we were to count the individual frequencies of each of these, you'd have too many different groups. It really wouldn't make any sense. So instead of just looking at each number individually, we're going to group each of the numbers into what's called classes, and each class needs to be exactly the same width. So if the first group, let's say, goes from 10 to 20, then the next group would also have that same width. So the next group might go from, let's say, 21 to 31, etc. All right, so let's look at the question at hand. It says here we want to create a frequency distribution using 6 classes. And our frequency distribution should include class, frequency, midpoint, relative frequency, and cumulative frequency. There's actually a few other options as well, so let's go over all of these in the video. So just to be clear, some of these items are looking at the counts or the frequencies, and some of them are looking at the labels of the groups. So when we look at midpoint and class, those are different ways of describing the group itself, not how many there are in each group, but just the group itself. There is also a third way called class boundaries. So this first group here, really those are called class limits, but there's also class boundaries. Then there's also ways of looking at the count. So we have frequency, relative frequency, and cumulative frequency. So let's explore all of that. Let's go here. Okay, so let's start with different ways of looking at the groups themselves. So there's 3 main ways. There are class limits, class boundaries, and midpoints. All right, so, and these are just different ways to describe the classes themselves. Basically, ways of labeling the classes. So to figure out what our classes are, we're going to have to go back to the story. It says here that we want a total of 6 groups. So how can we divide this data set into 6 basically equal chunks? To figure that out, we need to figure out what the range of the data set is, what the max minus the min is. To help us out, I've already sorted the data set. This can be done in StatCrunch. It can also be done in Excel, but it's much, much easier if you sort the data set first. And I sorted it in ascending order, so from lowest to highest. And we see here the lowest number is 40. And the largest number, the maximum, is 541. So our range is going to be our max minus our min. To figure out the class width, how big each class is going to be, we just take the range, the max minus min, and divide by the number of classes that we want. So in our example, our class width is going to be the max, which was 541, minus 40, divided by 6, because they told us we wanted 6 classes. If we take out a calculator, we will get 83.5. No matter what number you get here, you're going to want to round up to the next number. So in other words, even if we'd normally round to 83.5 up to 84 anyway, but what if it was 83.1? We would still round it up to 84. So whatever number we get there, we round it up. So always round this number up to the next integer. So our class width, I'll just use CW for class width, is 84. All right, so what do we do with that 84? What you're going to do is we're going to use this to construct our class limits. All right, so let me erase the screen and get going on it. So remember our class width. So we figured out our class width was 84. Let me make a note of that. All right, so if we want to figure out our class limits, there's going to be a lower limit and an upper limit. And I'll just use a hyphen notation, so lower to upper. This is not a subtraction. I'm just saying we'll put the lower number first and the upper number second, just to make it a little bit easier on us. Okay, so our first group is going to start at 40, because that's the minimum in our sample. Our next group, you're just going to take the 40 and add 84 to that. So 40 plus 84 is 124. Add another 84, and you get 208. Let me double check myself here. So let's see, 84 plus 40 gives me 124. Add another 84 gives you 208. If we add another 84, we get 292. Adding another 84 gives us 376. And adding another 84 gives us 460. We know we wanted a total of 6 classes, so now we have 6 groups. We can stop. And again, all I did was add 84 each time. All right, so as far as our upper limit goes, we can find the upper limit by keeping in mind that our first group is going to end one number before the next group starts. So because the second group starts at 124, the first group is going to end at 123, just one less than that. So our first group is going to end at 123. Our next group is going to be 208 minus 1, which is 207. And then 291, 375, and 459. Okay, what about the last group? Well, one thing you may notice here is that these are also separated by 84 each time. So if we just add 84 to 459, we'll get 543. Let me get rid of some of this extra writing so we don't get too cluttered here, but we would get 543. All right. Okay, so let's talk about another way of labeling these. Not every textbook does this, so if it's not asked in your homework question, don't worry about it. But if it is, I just want you to see this at least once. So another way to look at this is something called class boundaries. And where class boundaries are useful is we're also still going to have a lower boundary and an upper boundary. Is what happens if we're not just really limited to integers? What happens if our number could be something like 123.5 or 123.6 or 123.1? What do we do with that? Well, if we're dealing with numbers that are what's called continuous, where they can take on these decimals that can go on in many decimal places, we don't want to limit ourselves to just integers, and we need to account for every number. So to fix this, we're going to subtract 0.5 from each lower limit and add 0.5 to each upper limit. Okay, so let's do that. So instead of 40, if you subtract 0.5, you get 39.5. Subtracting 0.5 from 124 gives you 123.5. Then 207.5, then 291.5, then 375.5, then 459.5. All right. Now looking at the upper limits, we're going to add 0.5 to those. So we have 123, add 0.5, we're going to get 123.5, 207.5, 291.5, 375.5, 459.5, and 543.5. Okay, so that's just another way to label your classes. You do not have to do this unless the homework asks for it. And it's not really that commonly done in practice in terms of actually labeling the lines. However, it is commonly done with how software writes things, because software, when you're doing creating a graph like a histogram, you don't like spaces between your bars. You want one bar to kind of butt up right against the next. So to do that, you kind of eliminate the spaces using this class boundary approach. All right, so the third way to label each group is just to use the midpoint of each group. So to find the midpoint of each group, you just need to basically find the average of each group. And you can use either the class limits or the class boundaries. You'll get the same number either way. I'll use the class limits because the numbers are integers, so they're a little nicer to work with. So all you need to do is you need to take the lower limit and upper limit for each group, add them together, and then divide by 2. So it's going to be 40 plus 123 divided by 2. I'm just going to take out a calculator. I did 40 plus 123, got 63, divided it by 2, and I got 81.5. So the midpoint of that first group is going to be 81.5. Now, what's the midpoint? What's the middle number between 124 and 207? We'll do the same thing. 124 plus 207, divide that by 2, and I get 165.5. A shortcut you can take is, if you notice, the difference between each of the class limits, as we talked about before, is the class width, 84. And the same thing goes for the upper limits. The difference is 84. Same thing goes with the class boundaries. The difference between each of these is 84. So the difference between these are also 84. So if you don't want to do adding numbers and then dividing by 2, you can just add 84 each time. So if we add 84 to 165.5, you get 249.5. If we add 84 again, we get 333.5. Add 84 again, you get 417.5. And then add 84 one last time. The midpoint of that last group is 501.5. All right, so these are the 3 main different ways to label your different classes. Let's talk about frequencies. I've already filled up this page here, so let me copy part of this and just work with this part on the next page. Okay, so we don't need all those different labels. All right. So let's talk about different ways of calculating counts, essentially. So the most basic way is frequency, which literally just means how many observations in the sample are there in that class, in that group. Well, our first class starts at 40 and ends at 123. So looking at our data set here, it would start at 40 and end at 123. So 123 would be somewhere between 116 and 131. So how many numbers are in this interval? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 numbers here. What about in the next group? Between 124 and 207. So let's see. Well, 211 is bigger than 207, so our second line stops there. So there's only 3 numbers in the second group. The next group starts at 208 and ends at 291, which is going to be somewhere over there. So let's see, 1, 2, 3, 4, 5, 6. There are 6 numbers between 208 and 291. How many numbers between 292 and 375? Okay, repeat the process, and I get 1, 2, 3, 4, 5. 5 numbers. 376 to 459. And I get 4 numbers. And the last group gets 2. If any of our classes has no observations in it, has a frequency of 0, you're still going to include it. You'll just write a frequency of 0 there. You need that placeholder. You can't skip any of the groups. All right, so let's talk about relative frequency. Relative frequency is just a proportion. You could say percent if you want to convert it to a percentage, or just the proportion of the data set that falls in that group. So if we add up all the frequencies, we can get the sample size. And if you add up all these numbers, you should get 29. So if we just take 9 and divide it by 29, that will give us our relative frequency of that first group, of the first class. The directions for this particular homework question that I'm answering does ask for it to be in decimal form, going to 3 decimal places. I think it says the thousandth place, which is 3 decimal places. So I'm just going to do 9 divided by 29 in a calculator, and I get 0.310. All right, next, if I do 3 divided by 29 in a calculator, I get 0.103. Then 6 divided by 29, I get 0.2068, which would round to 0.207. 5 divided by 29, and these are just rounds like normally. So this would be 0.172. I didn't double check these calculations, so if I did make a mistake, just make note of that. Okay, if you want to double check to see if you did this at least somewhat right, if all these numbers should add up to be approximately 1. You might find out if you add up all these numbers, it might be slightly above 1 or slightly below 1. In fact, I think if you add up all these numbers, you might get 0.999. And that's going to happen very often. It's just because of rounding. Like, in other words, if you added 0.333 plus 0.333 plus 0.333, you're going to get 0.999, even though each of those are approximately 1/3. So, like, this happens with rounding, where sometimes things don't quite add up. And that's okay, but it should be close. If you get something like 1.5 or 0.4, you messed up. So just make sure they add up to something pretty close to 1. All right, the last thing is something called cumulative frequency. Often I just denote cumulative frequency with a capital F, but sometimes people just write it out. So this is called cumulative frequency. So cumulative frequency just means how many are in that group or a lower group. So looking at our first class, there are 9 observations in that first class. The second class has 3. So how many are in that class or a lower class? Well, that would be 9 that already happened, plus the additional 3. So 9 plus 3 is 12. Next, we're going to add another 6 to that. That gives you 18. Add another 5 to that. That gives you 23. Add another 4 to that. That gives you 27. Add another 2. That gives you 29. This last number here is always just going to be our sample size. And that's it. So this is how you can create a complete frequency table. Truthfully, most of the time you create a frequency table, you just use the class limits and the frequencies. You don't have to do all this other stuff. But sometimes you're asked to include relative frequencies or cumulative frequencies, or you might need to do different kinds of labeling. So this is everything. You can also do some of this, not all of this, but some of this in StatCrunch. So I'll show you that in a bit.